All right, homework 20 is the start of chapter 2, which is all about graphing. And it's going to first of all give us a couple formulas that we're going to use. This was later on in the chapter, and they've now moved it up to the very beginning of the chapter. So we'll go ahead and start with that. First one is the distance formula. The distance formula says that if I take the x value from point 2 minus the x value from point 1 and square it, plus the y value from point 2 minus the y value from point 1 and square it, that I can find the distance between these 2 points. Has to do with solving the Pythagorean theorem, but we won't go into that. So it is going to give us our 2 points. You don't have to name your 2 points. This point here, they tell you, is at negative 8, 2. So that's going to be my x1 and my y1. This point here, they tell us, is at negative 4, 8. So that's going to be my x2 and my y2. And I'm just going to plug those values into my distance formula. So I'm going to have the square root of x2 minus x1. So x2 is negative 4 minus x1 is negative 8. So I'm going to have negative 4 minus a negative 8 squared. And then I'm going to do y2 minus y1. So I'm going to have 8 minus 2 squared. And then I'm going to solve that. So I'm going to just simplify this first part. Negative 8 minus, or negative 4 minus a negative 8 would be negative 4 plus 8, which is 4. So 4 squared. 8 minus 2 is going to give me 6. So 6 squared. 4 squared is 16. 6 squared is 36. If I add those together, I get the square root of 52. Now, square root of 52 is my answer. It is not in simplified form, but it is in exact radical form. So if you wanted to stop there, you could. Better is if we simplified. We practiced simplifying in the review chapter. We said that I could factor 52, and I want to find a factor that is a perfect square that divides into 52. So if I check here, 52 is divisible by 4 13 times. So I would say, okay, this is 4 times 13. The square root of 4 is 2. So I would get 2 square root of 13. So it will take the square root of 52. It will say it's correct. However, 2 square root of 13 would be the better form of your answer. So either one of those will work. It will just remind you, if you don't simplify it, that that is the answer in simplified form. So on number 2 here, if we're using our distance formula, square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So my x value from point 1, my y value from point 1, my x value from point 2, and my y value from point 2. Plugging my numbers in. X value from point 2 is 3. I'm going to subtract my x value from point 1, which is 8. And then my y value from point 2 is 3. I'm going to subtract my y value from point 1, which is 6. So 3 minus 8 would give me negative 5 squared. 3 minus 6 would give me negative 3 squared. I would get 25 plus 9. If I add 25 plus 9, I get 34. So I have the square root of 34. Now, unlike on the previous one, square root of 34 can't be simplified. I have no perfect squares that divide evenly into 34. 4 doesn't divide into even 34. 9, 16, 25, and then I get to 36, and I'm already too big. So on this one, I can't go any farther than that. I'm just going to leave it as the square root of 34. And so if we go ahead and try the next one, using my distance formula again, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared And so here's going to be my x value from point 1 and my y value from point 1, my x value from point 2, and my y value from point 2. So the x value from point 2 is -4. I'm going to subtract the x value from point 1, which is a -7. Y value from point 2 is 8. I'm going to subtract the y value from point 1, which is 4. And then I'm going to simplify that. So here we have the subtracting a negative where I end up adding -4 plus 7 would give me 3. 8 minus 4 is 4. So I end up with 9 plus 16. 9 plus 16 is 25. And the square root of 25 gives me 5. All right, 4, 5, and 6, we're doing the midpoint formula. The midpoint of my line is halfway between, so if I estimated, it'd be somewhere right in there. Really, all I'm going to do to find the midpoint of something is to average the x's, get your x coordinate of your midpoint, average your y's to find the y coordinate of your midpoint. So my midpoint formula is going to look something like this. x1 plus x2 divided by 2. I'm adding my two x's and dividing by 2 to find the average. That's going to give you the coordinate for the x. y1 plus y2 divided by 2. That's going to give your y coordinate by finding the average of the y's. So I'm just going to use my values. Again, they're going to give me them. So this is my x value from point 1 and my y value from point 1. My x value from point 2 and my y value from point 2. So adding my x's, I'm going to have -5 plus 3 divided by 2. Adding my y's, -8 plus 6 divided by 2. Now I'm just going to simplify these. So here I'm going to get -2 over 2. Here again I'm also going to get -2 over 2. So simplifying, I get -1, -1 for my coordinates of my midpoint. Well, if I look at that, yeah, that looks like that possibly could be at -1, -1. Looks like it's in the right spot. So finding the midpoint, I'm just going to average the x's, add them together and divide by 2, average the y's, add them together and divide by 2. So number 5, same kind of thing. I want to find the midpoint. So I want to find the dot that's halfway between those two other dots if I just estimate where it is. So again, to find my midpoint, x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So adding my x's, I'm going to have 5 plus -1 divided by 2, and then I'm going to have 8 plus -6 divided by 2. 5 plus -1 would give me 4 over 2. 8 plus -6 would give me 2 over 2. And so I'm going to get the point 2, 1. So the coordinates of this point would be at 2, 1. Again, looks like it's a pretty reasonable answer. Now these don't always come out to nice whole numbers. Sometimes you will get a fraction because you might have 3 halves that you can't reduce, but that's okay. Now this is when you have the 2 endpoints and you want to find the midpoint. The third one, they're going to throw a little twist in there on you. This time we are going to have one of our endpoints, which is at 7, 2. It's going to tell us that our midpoint is at 2, -1, and it wants you to find the coordinates of Q. So what we end up having to do is break our formula down into 2 separate parts. For my midpoint x value, I'm adding my x's, x2, and dividing by 2. I'm going to do just that part of my formula and solve it for the x2. So the x value of my midpoint is the 2. The x value of my first point is the 7. So I have 2 equals 7 plus x sub 2 over 2. And I want to solve that for x sub 2. first thing I want to do if I'm solving that, get rid of my fraction. So if I'm going to get rid of my fraction, I've got to multiply by 2. So I'm going to times both sides by 2, cancel out my fraction. 4 equals 7 plus x sub 2. Now all I need to do is subtract my 7. So negative 3 is going to be the x value of my midpoint. Going to do the same kind of thing to do the y value. The y value of my midpoint is y1 plus y2 divided by 2. If I smush that in there, I should have given myself a little more writing room. Again, I'm going to substitute in the numbers that I know. So, the y value of my midpoint was negative 1. The y value from my first point was 2. So I have negative 1 equals 2 plus y sub 2 divided by 2. Now again I have to solve that, solving my equation, getting rid of my fraction. I'm going to multiply both sides by 2, cancel out my fraction. 2 times negative 1 is negative 2, equals 2 plus y sub 2. I need to solve this for y sub 2, so I'm going to subtract my 2, and I get negative 4. So, the coordinates of Q would be at negative 3, negative 4. You probably won't have a lot of those, but every once in a while I would hit one of those. And obviously it's a lot easier to do number 4 and 5, but that's how we would do it if we know what the midpoint is and one of our endpoints. We just break it down into 2 separate little problems, knowing what our midpoint formula is. Alright, the next part is just identifying solutions to an equation that has 2 variables. So we've been doing this since introductory algebra. All we're going to do is take our ordered pair, knowing that the first value is x, the second one is y, plug them in for the x and the y in our equation, and see if we get a true statement or not. So we're going to start on the first one. 7 times my x value, which is 1, minus 4 times my y value, which is 3. Do I get negative 5 for an answer? So I'm going to solve my left-hand side and see. So 7 times 1 is 7, minus 4 times 3 would be 7 minus 12. 7 minus 12 is negative 5. Yes, that one worked. Now I'm going to repeat it, only I'm going to use my next ordered pair, which is negative 3, negative 4. So 7 times my x value of negative 3 minus 4 times my y value of negative 4. Do I get that answer of negative 5? Well, this is going to give me negative 21 plus 16. If I do negative 1 plus 16, sure enough, I get negative 5. So then I try the next one, doing the 4 too. 7 times my x value of 4 minus 4 times my y value of 2. Do I get negative 5? 28 minus 8. 28 minus 8 is 20, not negative 5. So I get a no for that one. Repeat it one more time, this time using negative 2, positive 6. So 7 times my x value of negative 2 minus 4 times my y value, whoops, of 6. I'm trying to write negative 6 in there, but it's just supposed to be a 6. Do I get negative 5? So here I would get negative 14 minus 24. Negative 14 minus 24, definitely not negative 5. And so I'm just plugging my numbers in for x and y, checking to see if it's a true statement or not. Now on the next one, notice it's a little bit different. It just says y equals 1. This problem should be a whole lot easier than the previous one, because all I'm doing is looking at my ordered pairs and saying, is the y value equal to 1? Well, if I look at my first ordered pair, negative 4, 0, the y value is 0. No, it is not equal to 1. Then I look at my next ordered pair, My y value is negative 8. No, that is not equal to 1. Looking at my next ordered pair, my y value is negative 2. No, that does not equal 1. On the last one, however, my y value is 1. Yes, the y value of that point is 1, and therefore I get a yes. So if I have an equation that just says x equals my number or y equals my number, I'm just looking at my ordered pairs to see if the x value is whatever value or the y value is the given value and saying yes or no. Not a lot of work. So number 9, that little calculator screeny thing always is in my way. Here again is one we actually have to do the work for. I want to determine if it's a solution to 2x plus 5y equals 7. So I'm going to plug in each of my ordered pairs and solve. So 2 times the x value of negative 4 plus 5 times my y value, which is 3. Do I get an answer of 7 or not? So here I would have negative 8 plus 15. A negative 8 plus 15, sure enough, is equal to 7. So then I try the next one. So 2 times my x value of negative 9 plus 5 times my y value of negative 4. Do I get 7? So putting negative 9 in for x, negative 4 for y. Well, here I'm going to get negative 18 minus 20. Definitely not equal to 7, right? So then I try my third one. 2 times the x value of 7, plus 5 times my y value of 5. Do I get an answer of 7? Well, 2 times 7 is 14. 5 times 5 is 25. Is 14 plus 25 equal to 7? No. And then doing one last one. So this time I'm using 6 and negative 1. So 2 times my x value of 6 plus 5 times my y value of negative 1. Do I get that answer of 7? 2 times 6 is 12. 5 times negative 1 is minus 5. 12 minus 5, sure enough, does give me an answer of 7. And so I'm going to mark yes. The next ones, we are graphing the line in the form of y equals mx. Because you're in college algebra and you hopefully have done some graphing and understand slope and y-intercept, I'm going to graph this 2 different ways. You can pick which way you like. So, general form of equation, y equals mx plus b. I should really call that slope-intercept form. This value here is my slope. This value here is my y-intercept. Back in introductory algebra and intermediate algebra, we said if we were going to graph a line, we were just going to make a table. And we were going to plug numbers in for x, find our y's. We said most of the time we can just use 0, 1, and 2. Sometimes you might use a negative 1 if it's not fitting on your graph. But nice, easy numbers to work with. If I picked 8, 3 times 8 would be 24. It wouldn't fit on our graph. So we just use nice, small, easy numbers to plug into my equation and solve. So starting off with the 0. 3 times 0 just gives me 0. 3 times 1 would give me 3. 3 times 2 would give me 6. 3 times negative 1 gives me negative 3. Now technically to do a line you only need 2 points. We suggest on Alex that you do at least 3. That way if you mess up on plotting one of your points or you solved it incorrectly, you can see that it doesn't line up nice. You can do more than 2 or 3, but I would suggest you do at least 3 and then plot your points to see if they do make a line. So again on Alex, they're assuming you already know how to plot points because you're in college algebra, but just to remind you, The first number is your x direction, the second one is your y direction. So the first one is left or right, second one is up or down. 0, 0 obviously is just right in the middle. 1, 3 means I'd go 1 to the right, up 3. 2, 6, 2 to the right, up 6. -1, -3 means I'd go 1 to the left and down 3. Notice those all still line up. You're going to have a little tool that sort of looks like this. It looks like a line with 2 X's. You're going to click on 2 of those dots, and that line then should go through all of your dots. There's my line, what we did in introductory algebra. Now, because I know that you are going to have to work with slope and y-intercept later, I want to talk about that now. If I put this equation in this form, I would have y equals 3x plus 0. There's not a number on the end. It means that 0 is your y-intercept. So right here is your y-intercept at 0. Yep, I crossed the y-axis at 0. The 3 is your slope. Slope. They say that's the rise over the run. So when I have a slope of 3, I would write it as a fraction. 3 is 3 over 1. The top number, although they call it rise, is up or down. It's the change in the y value. The bottom number, I always go to the right, but it could be right or left. So if my slope is 3 over 1, it means that I would go up 3 and to the right 1. So from this dot, I go 1, 2, 3 up over 1. 1, 2, 3 up over 1. And I get my other points. Now I have to remember that if my slope is positive, another way to get a positive slope is to have a negative over a negative. If I have a negative over a negative, I would go down 3 and to the left 1, since they're both negative. Down 1, 2, 3 and to the left 1. Down 1, 2, 3 and to the left 1. If I was drawing straight, my line's a little crooked, it should go through those dots. So, I can graph by either making a table and plotting points, or I can graph by using the slope and the y-intercept. My y-intercept is 0, my slope is 3, so I went up 3 over 1. Up 3 over 1. Now I have my points and I can draw my line. To me, graphing with the slope and the y-intercept is quicker, but they don't introduce that till later. Since we've already done it in introductory and intermediate algebra, I'm going to talk about it in both places, just so you get lots of practice. So, number 11. Same thing on number 11. If I were going to make a table, I would just put in nice, easy numbers, plot my points. So, -5 times 0 is 0. -5 times 1 is -5. -5 times 2 is -10. Oops, my graph doesn't go that far, so maybe I have to use -1 instead. -5 times -1 is a positive 5. So 0, 0, right in the middle. 1, -5, 1 to the right, down 5. -1, 5, 1 to the left, up 5. Now before I draw my line, I'm going to graph using my slope and my y-intercept. Again, there's nothing on the end, so my y-intercept is just at 0. That's that same point we got, 0, 0. My slope is -5. So I would write it as -5 over 1. Notice, it's a -5 over a positive 1, or 5 over -1 would be the opposite way. So I either go down 5 and to the right 1, or up 5 and to the left 1. So down 5, 1, 2, 3, 4, 5, and to the right 1, or up 5, 1, 2, 3, 4, 5, and to the left 1. Notice I ended up with the exact same dots. Connect my dots and draw my line. On Alex, of course, it'll make the line straight, unlike my drawing. So, Either make a table and plot points, or plot your y-intercept and use your slope to find the next points. Number 12, what happens when I have a fraction? Whoa. Y equals 2/3 x. When I make my table, I have to pick out numbers that are going to work out nice with 2/3. I wouldn't want to put 1 in for x because 2/3 times 1 is 2/3, and that's hard to plot. So when I pick values for x, 0 is always good. Then I want multiples of my denominator. 3, 6, and if I have to do negatives, -3, -6 would be good choices. So if I have fractions, I'm going to use 0 and then multiples of the denominator. So 2/3 times 0 is just going to be 0. 2/3 times 3. 3's cancel out, I just get the 2 on top. 2/3 times 6. 3 goes into 6 2 times. 2 times 2 is going to give me 4. 2/3 times -3. 3 goes into -3 a -1 time. -1 times 2 is a -2. So practice working my fractions. Again, plotting my points. 0, 0 right in the middle. 3, 2. 3 to the right and up 2. 6, 4. 6 to the right and up 4, -3, -2, 3 to the left and down 2. There are my dots. Now, to me, quicker than that is just using the slope and the y-intercept. Again, my y-intercept is 0 because there's nothing on the end, and so 0, 0 is my y-intercept. My slope is 2/3. Or -2 over -3 because I have a positive slope. So I could go up 2 and to the right 3, or down 2 and to the left 3. So from this point, up 2 over 1, 2, 3. Up 1, 2 over 1, 2, 3. Or down 2 and to the left 1, 2, 3. Down 2 and to the left 1, 2, 3. I have my dots. If I could draw straight, I could draw my line. So up to you. If you want to make a table, you can make a table. If you want to practice with the slope and the y-intercept, which you are going to have to do later, you can do it that way. (13, 14, and 15). Now we are going to graph the ones that are in slope-intercept form. So y equals mx plus b. End number is my y-intercept. Number in front of the x is the slope. So again, 2 ways I can graph that equation. I can either just make my table, plot my points, or I can use my slope and my y-intercept in order to get my points. So again, if I make my table, since there are no fractions, I usually just use 0, 1, and 2. If I need to, I'll use -1 if I'm running off of too big a numbers and I don't fit on my graph. Plugging them in. -3 times 0 plus 3. Anything times 0 is 0, so I just get the 3. -3 times 1 plus 3. This would be -3 plus 3, and -3 plus 3 is 0. -3 times 2 plus 3. This would be -6. -6 plus 3 is -3. So plotting those points, 0 over up 3 is 0, 3. 1, 0. 1 to the right, up 0. 2, -3. 2 to the right, down 1, 2, 3. There are my dots. That would be if I was going to plot points. If I'm going to use the slope and the y-intercept, I start with my y-intercept. My y-intercept is at +3. Here's my y-intercept. On the y-axis, right at +3. My slope is -3. So we write it as -3 over 1. So from that point, we're going to go down 3 and to the right 1. So 1, 2, 3 down to the right 1. 1, 2, 3 down to the right 1. You can see I get the exact same dots. And if I could draw straight, I would draw my line. Again, you don't have to do it both ways. One way or the other, whichever way you like to do. I'm just giving you some options since you're in college algebra that you should hopefully kind of know both of these two concepts. So number 14, again, we are going to graph the line, -4x plus 5. Again, there aren't any fractions, so I would just use nice, easy numbers like 0, 1, and 2 if I'm going to make a table. So I'm going to plug my numbers in. -4 times 0 is 0. 0 plus 5 is 5. -4 times 1 is -4. -4 plus 5 is 1. -4 times 2 is -8. -8 plus 5, -3. So 0 over up 5, 1 over up 1, 2 over down 1, 2, 3. There are my dots. Using my slope and my y-intercept. My y-intercept is that number on the end, the +5. Right there is where I'm touching my y-axis. Notice that's the same value I get when x is 0. My y-intercept always has 0 in for x. My slope. My slope is -4. I'm going to put it over 1. So I'm going to go down and to the right. So if I started here, I would go 1, 2, 3, 4 down and to the right 1. 1, 2, 3, 4 down and to the right 1. Notice I have the exact same dots. If I could draw a straight line, it would be through those dots. I didn't mention this before, but notice that if my slope is negative, when I connect my dots, I'm going downhill as I go from left to right. If my slope is positive, I'm going uphill as I go to left to right. So if you think about a hill, my slope is positive if I go up as I go from left to right, negative, and so I know I have a -4 slope. I should be going down as I go from left to right, connecting my dots. So number 15, we have a positive slope. We should be going up as we go from left to right. So again, on number 15, 2 ways to do my problem. The basic way is just to make my table, plug my numbers in, and solve. So again, there are no fractions. I'm just going to use nice, easy numbers, plug them in. So 2 times 0 is 0. 0 plus 3 is 3. 2 times 1 is 2. 2 plus 3 is 5. 2 times 2 is 4. 4 plus 3 is 9. 7. Okay, and add. 4 plus 3. I was looking to see how high my graph went. So 2 times 2 is 4. 4 plus 3 is 7. Now I can plot my points. 0 over up 3. 1 over up 5. 2 over up 7. There's my dots. Again, if I choose not to make a table, just in case I make a silly math mistake, I can use my slope and my y-intercept. On this one, my y-intercept is at +3. So at +3, I have a dot on my y-axis. My slope, in this case, is a +2. So it's up 2 and to the right 1. So up 1, 2, to the right 1. Up 1, 2, to the right 1. Again, as I connect my dots from left to right, boy, that's a really curvy line. I'm going uphill since my slope was positive. So up as I go from left to right. Type C now, they're going to throw in the ones that have fractions for slope. Again, if you happen to choose to make a table, Since I have a fraction for a slope, I have to be a better picker for my numbers. I don't want to use a 1 because taking half of 1 gives me 1/2. So I want things that work out nice with my 2. So 0, 0 is always good, 2 and 4. I could use -2 if I wanted to. Multiples of the denominator, so multiples of 2, 2, 4, 6, 8. -2, -4, -6, -8. Pick my numbers, I'm now going to plug them in and solve. So half of 0 plus 3. Well, anything times 0 is 0, so I just get 3. 1/2 times 2 plus 3. Here the 2's cancel out. 1 plus 3 is 4. 1/2 of 4 plus 3. 2 goes into 4, 2 times, 1 times 2 is still 2, 2 plus 3 is 5. So plotting my points, 0, 3, 2 over up 4, 4 over up 5. So I can make my table, or I can use my slope and my y-intercept. This time, my y-intercept is at 3. There it is, right on my y-axis at 3. My slope is 1/2. So I'm going to go up 1, to the right 2. So from here, up 1 over 1, 2. Up 1 over 2. Notice I got the exact same dots as if I use my table. My slope is positive, so I'm going uphill as I go from left to right. Number 17. Again, if I make a table, I have to be a better picker than just using 0, 1, and 2. 0 is always good. In this case, I look and I have a denominator of 3. So 0, 3, and 6. If I need to, -3. Plugging those in and solving. So -2/3 times 0 plus 2. Anything times 0 is 0. I just get the plus 2 on the end. -2/3 times 3 plus 2. 3's cancel out. I get -2 plus 2, which is 0. -2/3 times 6 plus 2. 3 goes into 6 2 times. -2 times 2 is -4. -4 plus 2 is -2. So plotting my points, 0 over up 2, 3 over up 0, 6 over down 2. There are my dots. Using my slope and my y-intercept. My y-intercept, boy, I have a lot of positive y-intercepts. My y-intercept is at +2. There it is. On my y-axis, I'm at 2. My slope is -2/3. I like to put the -2 on top, so I have a -2 over a +3. So I am going to go down and to the right. So from here, down 2, to the right, 1, 2, 3. Down 2 and to the right, 1, 2, 3. I have the exact same dots. Because my slope was negative, I'm going downhill as I connect my dots from left to right. Number 18, same kind of thing. I'm graphing. I happen to have a fraction. So if I make my table, I have a denominator of 4, so I'm going to use 0, 4, and 8. If I need to, I'll put a -4 in. So plugging that in, -1/4 times 0 is 0. 0 minus 4, I'm going to get -4. Putting my 4 in there. If I put a 4 in there, the 4's cancel out. I'm going to get -1 plus -4, which is -5. Then I'm going to put my 8 in there. If I put my 8 in there, 4 goes into 8 2 times. 2 times -1 is -2. -2 minus 4, -6. So 0 over down 4, 4 over down 5, 8 over down 6. There are my dots. That's if I make my table. If I use my slope and my y-intercept, my n number is my y-intercept. Hey, this time I have a y-intercept that's negative, so my y-axis, I'm at -4 to start with. My slope, again, I like to put the negative on top, so I'm going to go down 1 and to the right 4. So down 1 and over 1, 2, 3, 4. Down 1 and over 1, 2, 3, 4. Again, since my slope is negative, as I go from left to right, I should be going down, and I am. So, graphing when you have a fractional slope, I have to either be a pretty good number picker, making sure I use multiples of my denominator, or again, I can simply use my y-intercept and my slope in order to plot my points. (19, 20, and 21) tell me I'm going to graph vertical or horizontal lines. Vertical lines go straight up and down. Horizontal lines go straight across. You get a vertical or a horizontal line when you have x equals a number or if you have y equals a number. It doesn't have both the x and the y that cause you to have that slant in the line. So, if I think about this the long way, if I have x equals -1, it means if I were going to make a table that every value that I use for x has to always be -1. Every point has an x value of -1. The y values can be whatever I want. Maybe it's 0, maybe it's 2, maybe it's -3, maybe it's 5, whatever you want to pick. So if I were to plot those points, -1, 0 would be right here, -1, +2, -1, -3, -1, 5. Notice what happens. My line ends up going vertical, straight up and down. So what I do is, I know that x has to equal -1. On my x-axis, I mark where -1 is. I know that since it's an x equals a number, that it has to go vertical. In other words, up or down. So I take my line tool, I either mark a point that's straight up or a point that's straight down, and then I can have my line that goes straight up and down. So again, if you understand the concept of here's my table and all my x's have to be -1, I could make a table and plot points. If I understand that my x equals a number has to be a vertical line, I can just mark on the x-axis. Here's my -1. I know my line has to go up and down, so I mark a point up or down, and then I can draw my line. You only technically need 2 points. Again, if you want to mark 3, you certainly could. Well, same thing kind of happens when I have y equals a number. If I have y equals 3, it means in my table, all of my ordered pairs have to have a y value of 3. My x values can be anything. Might be 0, might be -2, might be +5, whatever I happen to pick. So 0, 3, 0 over up 3, -2, 3, 2 to the left, up 3, 5, 3, 5 to the right, up 3. Notice that if I have y equals a number, it's always going to go horizontal. It should be straight across. So what I do knowing that is I mark my y value of 3. I know it has to go horizontal, so I mark a point to the left or to the right, and then I can just make my line going straight across if I could draw straight. So if I were going to graph the line y equals 8 without making my table, I would just say, okay, my y value has to be 8. It's way up here. I know that this line has to go horizontal. So, has to go left and right, so I make a point either on the left or on the right, and then I can draw my line. If I wanted to, I could have made my table, putting 8 in for my y values, and picking numbers for my x values and plotting my points. 0, 8, 2, 8, -3, 8. And you can see they all landed on that same line. So it's a lot quicker to do this if you remember that that has to be a horizontal line. I mark y equals 8, has to go horizontal, so I mark another point so I can go straight across. Otherwise, I can make my table and I still get the same line.